So atoms. First is the Thompson's model of atom, or it is also called plum pudding model. So from class 8 we have been studying this thing. Correct. But what we have to study in this is the main drawback of this plum pudding model. Okay. So the main drawback of this is this model cannot explain scattering of alpha particle through the foil. Okay, yeah. So then came the Rutherford model. So this is also called as the Geiger. Okay, this experiment is also called the Geiger and Marsden experiment. Geiger and Marsden experiment. So in this experiment, okay, what they found also I'll tell you. Very important thing. So on the scattering of alpha particles, this means scattering spelling, SCATTERING, scattering of alpha particle. Okay, so most of the alpha particle went undeviated. Most of the alpha particle passed undeviated through the thin foil. Okay, but some were scattered through very large angles. Okay, fine. So the important thing in the Rutherford is nothing but he was able to explain large angles of alpha scattering. The important thing is this, he was able to explain large angles of alpha scattering. This is the only thing we can get from this experiment. And then if you ask me about the disadvantages of this, so first disadvantage, stability of the atom cannot be determined. Second thing is, again, it cannot explain the origin of spectral lines. So why I wrote these things in red color or important thing, because again in entrance, they can ask in options. Okay, what are the disadvantages? Stability of an atom, cannot explain original spectral lines, and some other thing they can ask. Correct? So for that purpose only, I have given you this particular explanation. Highlighted the same. Then one important term is there, impact parameter. So it is defined as the perpendicular distance of velocity of alpha particles from the center of the nucleus. From the center of the nucleus when it is far away from the atom. So guys, whenever you are reading this chapter, you should have this particular thing in mind, the one which I'm going to draw. So this is the nucleus, center one. This is the atom thing. Basically, this is the atom. Okay, so these things should be there always in our mind. So perpendicular distance of velocity of alpha particle from the center of the nucleus. Center of the nucleus is here, correct? When it is far away from the atom. So this is called the impact parameter. Okay, it is represented by, this is B. Alphabet for this is impact parameter is B. So where in the formula sheet I'll be giving you about these things. Fine. Now coming to the most important formulas. Okay, energy E is equal to h nu. Okay, fine. Nu is the frequency, and also nu is equal to what? C by lambda. This is one of the most important formula which is asked in almost all the entrance examination or the board exam. So E is equal to h C by lambda, so you can put it. Okay. And one more important thing, after Rutherford, who came? Bohr came, correct? Bohr's theory. So I'm just going to write the most important thing in this, which will be asked for the, obviously you have to study the Bohr's postulates, correct? Very easy, and we've been studying it from the class 11, starting from structure of atom. Okay. One of the most important point in this is the angular momentum L of an electron in the stationary orbit is an orbital, is an integral multiple of h by 2 pi. So which means L is equal to nh by 2 pi. Okay, the angular momentum is what? L is equal to nh by 2 pi here, where n is equal to 1, 2, 3, and h is the Planck's constant respectively. Clear? So this is one of the important things which will be asked in the entrance examination, whatever it is. Obtain an expression for the energy of an electron in the hydrogen atom using Rutherford model of atom. So whenever you get atom thing, first thing is you draw the atom. So draw one atom and keep. So this black thing is nothing but our nucleus. Correct. So nucleus charge. Now I'll just draw the radius and everything. Plus ZE, the nucleus charge. R be the radius. So solution for this. So first one, ZD, the positive charge, correct? It is the charge of the nucleus. So R is the radius of the circular orbit of the electron. Then I given here V is the velocity of the electron. Okay. And energy. Total energy is equal to what? Kinetic energy plus potential energy. This is for a stable orbit. Okay. But again, we should always remember that Rutherford was unable to explain stability of the orbit. Fine. So, but for stable orbit, centripetal force is equal to electrostatic force. Centripetal force in the sense the force acting on the center, electrostatic force. That is nothing but our Coulomb's law only. The product of two charges is directly proportional to the what? So that is our Coulomb's law thing. That is according to our Coulomb's law. Centripetal force formula is thing but mv square by r. So this is 1 by 4 pi epsilon naught. Correct. The electric field is directly proportional to the product of two charges and inversely proportional to the square of distance between them. That's the thing in this particular thing. So two charges. One is the electron. Correct. One is this charge. And other is the nucleus charge. One is the atom charge and another is this nucleus charge. So there are two charges available. There is Q1, Q2. We will make it as what? One is ZE and E. ZE into E by R square. Correct. So now what I do is, and what is my M here? M is the mass of the electron. M is the mass of the electron. Now I divide everything by what? 2. But before that I can cancel one of the thing. R square and this R I can cancel. And I divide by 2 on both the sides. Okay. So why I am doing division by 2? That also we should know. Why we are dividing. Because kinetic energy is what? Half mv square. So for this purpose, I am dividing this. So I'll get kinetic energy is equal to 2 into 4, 8, 1 by 8 pi epsilon naught into ZE square by R. This is my kinetic energy expression. So I have completed this particular thing. Which one? This one. Now I have to just find what my potential is. So this we have to put it in a box and keep. Kinetic energy expression. Next thing is you have to find the potential energy. So for example, electrostatic force I am telling, right? So normally the Coulomb's law is 1 by 4 pi epsilon naught into Q1 Q2 by R square. Correct. Whereas in my electrostatic potential, that is in your second chapter in physics, the only thing is if I remove this or if I erase this 2 by R, it will become what? Electrostatic potential. That's all. So I'm just going to remove this R. So this will become my potential energy here. Okay, this expression. So I can just write potential energy is equal to 1 by 4 pi epsilon naught Q1 Q2. So that is ZD into, I can write E. That's it. Okay, ZD into E. And if I want to include the charge of the electron as negative, I can put a negative side also. For the electron-electron repulsion here. That's it. In electrostatic potential, generally for electron-electron repulsion, that also you studied in your last year class 11th VSC PR theory. Okay, class 11th. Electron-electron repulsion into R. R square I am not putting, R I am putting, that's it. So I'll get potential energy is equal to 1 by 4 pi epsilon naught into ZD square. Minus and I can put it here by R. Now my energy, total energy is nothing but kinetic energy plus potential energy. So this also I'll put in a box and keep. So Z E square by 8 pi epsilon naught R minus ZD square by 4 pi epsilon naught R. So upon simplification, I'll get what? This 1 by 8 minus 1 by 4. So obviously I'll get what? Minus of ZD square by 8 pi epsilon naught R. That's it. On simplification, I'll be getting this.